Hello friends, welcome. Friends, this video is going to be all about FWA. What is FWA? Fixed Wireless Access Devices. Now friends, you know that after the deployment of 5G, the operators have now started working to enhance the broadband subscriber base of theirs by using 5G as a technology for service delivery. Earlier, broadband was based on either copper, which is called ADSL, and optical fiber for providing this service. But 5G has empowered the operators to use wireless spectrum to provide broadband connectivity, which was unthinkable before 5G came into being, because 4G this was not possible. Now friends, what I'm going to do in this video is I'm going to take you down deep to understand how 5G capabilities have been unlocked by the operators to provide this service, and what importance this technology is having and will continue to have in future, and what are the constraints. That's all I'm going to talk about in this video, and this is not going to be a video at a very high level, but it is going to give you deep insights of the technological capability without you having any understanding of technology. That is what you're going to get from this video. So watch till the end. It is going to be very useful. Now friends, before I get into the details of technology, I will like to tell you what is the current situation as far as the subscriber base of the various mobile operators are from a wireline perspective, and how their subscribers are increasing over a period of time, has increased over a period of time. So if you see Reliance Jio, so I have chosen here wireline in one of my charts which I have posted in my website. So you see that I have chosen wireline, and I have plotted all the operators. So we'll focus on Reliance Jio, and it's a cumulative subscriber base. So you'll see that Reliance Jio has within the 14 months time has increased their broadband subscriber numbers from 10.7 million to 16.3 million, right? Which was pretty low, earlier, right? The rate of increase was pretty low, but now it has substantially, it is like kind of ramping up. Bharti is not that, their increase of subscriber density has not caught up to what Reliance has been able to do, solely because of the fact that they have not, gone all out on FWA. Now they are going all out on FWA, and I'm going to give you the reason why Bharti has lagged compared to Reliance, and what were the network constraint which kind of did not allow them to deploy FWA at the first place. Okay, so having seen this, let's go to a slide deck that I have prepared to give you this concept. Now, since I have to zip everything in a matter of 20 minutes, that is the maximum which I'm going to go. So I will go very fast, but I will do it in a manner that people will be able to understand this concepts of technology, which is going to lead to the service delivery of FWA. So first concept that we need to understand is that what is channel capacity. Now, don't get overwhelmed by this, because it is going to be very simple. Just have confidence in me and go with me, right? Now, what is channel capacity? Channel capacity is very simple. So let me just give you an example of a water pipe. Now, the water pipe has got certain, diameter. Now, you cannot thrust, whatever you do, you cannot thrust a certain amount of water at a certain speed from the pipe, because if the pressure will be so high that the pipe will burst. So there is a limitation in which is basically depending upon the constraint of the pipe, is physical construction, all that makes the pipe constrained to deliver a certain rate of water. Similarly, a wireless spectrum of a certain bandwidth is constrained by certain limitation to deliver a certain data rate of speeds, certain speeds of data transmission. And why it is that? And this is basically called channel capacity, theoretical maximum channel capacity. And this is because of the fact that when you are having a channel, you are constrained by the total bandwidth, which is the diameter of the pipe. You are constrained by the signal strength, because you can't be pumping too much water in the pipe, right? There is a limit to which you can pump, otherwise the pipe will burst. Similarly, you can't be pumping too much power in the channel. We were limited by regulatory constraint and the capability of the transmitter. So there is a limitation in that, and then there are certain noise which is floating around in the space, and those noise will increase depending upon the width of this pipe or the width of the channel, which is called bandwidth, right? So therefore, because of this limitation, there is a concept called Shannon theorem, which limits the maximum capacity of a channel. So these are two pipes which you see. One is in the transmit direction and another the receive direction. Both will have a limitation called channel capacity. So conventionally what happens is that whenever you are using a wireless system, because the pipe from the base station to the subscribers which are being served within the jurisdiction of the base station is a common pipe, therefore the pipe is constrained, therefore each and every subscriber is sharing that pipe, and therefore their ability to use data gets limited by the number of users which are present within that particular pipe, right, which is being served from the base station. So that is a single pipe, and that is why this constraint comes. Now what happened was that, let's go to the next concept. What we have done is, in case of 5G, we have been able to transmit multiple pipes emanating from the base station's antenna system. Now you might find this is strange. Normally, in 2G, 3G, and even in 4G to some extent, this pipe, which is this RF wave, which I call pipe, is just one for a particular sector. There are not multiple pipes. But in a conventional 5G system, you have an antenna system which can drive multiple such pipes. And each and every pipe can either serve one single device or a group of device which is catering to this pipe. Right? So if you have multiple such pipes, then what happens is that you are not constrained by the physical capacity of one pipe. Since you have multiple of those, so therefore let's say if you have got 20 megahertz of bandwidth, and if you have multiple such pipe, then you are segmenting the channels, segmenting the space into multiple pipes. So there your capacity increases multiple fold depending upon the number of RF channels, paths that you are able to serve, because every path will be serving a different set of device, right? That's all you understand. Now, friends, let's come to the concept of how these pipes are configured. And this is a little bit of technical, and I want you to understand this concept. Otherwise, you will not be able to appreciate, how you can have so many pipes or so many RF beams running from the base station, right? Or the mobile device, depending upon what frequency of operations you are in. So what we need to do here, let's understand this, and again, be with me and don't get distracted and don't get overwhelmed by these charts, because these are very simple charts. Now, what I have shown you is multiple antennas which are closely packed with each other. So when you are looking from the top, you can consider this as a vertical line, right? Where you are looking from the top. This is the elevation of the diagram, right? So you have got one vertical line, which is an antenna system. Like you have seen in the base station, there are lines, right? Or there are bars of an antenna system. I am looking from the top. So this is one line. This is another antenna. This is another antenna. Now, you have the capability to feed different currents into the antenna in order to generate this RF beam that you see here. This RF beam gets generated because you are feeding current, means there has to be some electrical signals which are going to flow into these antennas. Now, these electrical signals are sinusoidal in nature, right? So they follow a certain frequency. So they go up and down like this, right? So all electrical signals will go like this in up and down. So when you go up and down, this up and down is nothing but a wave. Now, every wave will have a different phase, means at the point when the wave becomes maximum, there could be another wave which actually may become minimum at that point, depending upon what was the starting point of this wave, right? So what we are doing here, we are feeding these two different antenna system with two different phase angles. Now, when you are feeding these two antenna system with two different phase angle, what is happening is that you are creating these RF waves which are emanating out of this antenna system. You see? Now these RF waves are going to travel different distances depending upon what is the phase angle which you are feeding into this antenna system. Therefore, they will constructively interfere or destructively interfere, just like when you put two pebbles in a water and watch the waves emanating out of those two pebbles constructively interfere and destructively interfere to create a pattern. Now that pattern gives an indication that something is moving in the forward direction. That's all is happening here. So you can see this RF beam emanating out of the pattern because of this constructive and destructive interference happening at the wavefront, which is being fed by different currents which are flowing into this antenna system. That's how you are able to create an RF beam. Now friends, depending upon what the phase angle that you feed into this antenna system, you can steer the RF beam in different directions. That is called beam steering. You got it now? It is as simple as that. And by doing so, if you have multiple of these antennas in antenna, like I showed you here, this is the diagram that I'm showing you here. So this diagram, if you go here, you'll see there are multiple such antenna, and therefore you will be able to drive multiple such beams which can be steered in different direction depending upon what you need, right? So this can go in this direction, this can over. So every device will be serving by a different mean. Even the beam can be steered to point to the particular device even when the device is in mobile, right? They are mobile. So this is how you are able to overcome the physical limitation of the bandwidth which has got a maximum capacity by driving multiple such beams. Okay, I think this is clear, right? Now what happens is that let's talk about concept 4. The concept 4 is also pretty important, that BTSs can support multiple beams but not mobiles. Now why it is like that? Why I'm saying that a base station is capable of supporting multiple beams and not mobiles? The reason is again to do with frequency and the size of the BTS antenna system. Because if you look at typically a BTS antenna system, you will find that BTS antenna system is typically very overwhelming. Means they are large, this is like this. You can see something hanging from a tower like this. So because they are large, you can pack large amount of antennas in typically a base station compared to mobiles. Because the size of the antenna has to be directly proportional to the wavelength, right? So when you have wavelength of a particular dimension, because the frequency is fixed, let's say if you are transmitting a 3.5 gigahertz band, so your frequency is fixed, so your wavelength will be fixed. In BTS, you can pack multiple such wavelengths, and therefore you will be able to generate beams in different direction in case of BTS compared to mobile, where the real estate that is available to you is pretty small. Here the number of antennas will be pretty small compared to base station, where typically in 3.5, 16 antennas are typically packed. So you will have multiple beams emanating out of the base station compared to those of the mobile. In case of 3.5 gigahertz band, a mobile generally doesn't do any beam splitting. But if you are going to higher frequency, let's say 26 gigahertz band, then this physical constraint can be overcome because the wavelength will become still smaller. So then the size of the mobile may not be constrained to pack a large number of antennas. So the mobile will then start to do beam steering or beam splitting, just like a base station is capable of at a lower frequency, just because of the size of the base station. Okay, so that is the fourth concept. That was the fourth concept. The fifth concept is FDD versus TDD. Now, what is FDD versus TDD? It is important to understand it. Then only we will be able to truly appreciate FWA. Otherwise, we won't be. Now, the concept of frequency division multiplexing. Again, those viewers who do not have any understanding of this subject, please don't get overwhelmed. It is very simple. Look at this analogy which I have showed you here, right? So you can see here that there are two different roads running inside a tunnel. So this two different roads that are running inside the tunnel is a representation of a FDD system. And when you have one single tunnel, right, where only you can say that the cars are going in one single direction, this is a TDD system. This is a TDD system and it is an FDD system. So it's almost like a transmitting path dedicated for traffic moving in one direction and a receive path dedicated for traffic moving in the other direction, just like you see here. Whereas in case of time division duplex, you only have one single lane and the traffic can move only in one direction at a time. So there is nothing which is going back in time. So this is important. These are not simultaneous up and down transmission happening. It is not like that. It is like one direction transmission happening on a time, and the reverse direction transmission is going to happen only when this BTS stops transmitting. You got it? Right? So that is the concept number 5. Now come to the concept number 6. So TDD channels are always asymmetric. This is an important concept to be understood. Why TDD channels, time division duplex channels, are asymmetric? The reason is that it has to do with base station and the power limitation of mobile devices, right? And typically how the services are typically deployed or used. Mostly you are downloading movies, you are not uploading. But conventionally now the uploads have also become significant. So we generally don't like asymmetrical channels anymore. But if you are doing heavy downloads, then asymmetrical channels work. Even in satellite also, this problem is not going to be overcome because the satellite channels are going to be asymmetric. And let me explain to you why. The reason a TDD channel is asymmetric is because BTSs, the base stations, are able to transmit at high power. Now, when you are transmitting at high power, then you will be able to dedicate a large amount of resource in this channel, right? Which is a TDD channel, compared to mobiles, which do not have the capability to transmit at high power. They are limited by their form factor and the battery size. So what happens is that in the forward direction, the BTSs typically are able to get a larger resource from this channel, right? The time slots are larger, large amount of time slots resources are blocked in this channel for base station compared to the mobiles. And that is why the mobiles are not able to upload with the same kind of capability which the BTSs are able to upload. Now there is a difference here. There is a subtle difference here. If this mobile is an FWA, then the FWA can be configured with a larger power because it will be actively powered on a power source. But in a practical situation, you will not be able to do that because of the following reason, which I am going to come to the next slide. Concept 7. Typical FWA system. Now you see that we have a base station with multiple FWA which are hooked on the top of the house, and then cables running inside the house to provide Wi-Fi connectivity. We're sharing a same channel with the mobile system. Now what happens, friends, is that because the mobiles have limited power capability, and now they are sharing the same bandwidth or the same channels with the FWA system. So whatever configuration that you decide, 1:3, 1:4, 80-20. 80-20 means 80% of the time the base station is transmitting in one direction and 20% time the mobiles are transmitting in opposite direction. It is going to have to be reflected in FWA also. Otherwise, the frames are not going to collaborate with each other. There will be interferences. So you can't have the FWA system configured into a different ratio of transmit and receive compared to the mobile when they are sharing the same system. And therefore, when you are having a mobile system working on the same system where the FWA is working, you are limited by what kind of configuration you have set for mobiles. And that's why the FWA systems will follow the same configuration for mobile, and typically it is 80-20, right? So 80% of the time the BTS is transmitting, and the 20% of the time, the 80% of the time the BTS is transmitting, and the 20% of the time the FWA is transmitting. Therefore, uplinks are going to be 20% of the is going to be 1/4 of the downlink speeds, right? Then comes a very, very important concept. Why Bharti has not been able to deploy FWA, right, with that level of intensity as what Reliance has been able to do, which is to be understood. This is to do with 5G SA network. Now you need SA network for the FWA system to work. You can't really deploy an FWA system without an SA network. What is SA? Standalone 5G network. Now, difference between standalone and non-standalone 5G network is that in case of standalone 5G network, the 5G network is completely independent of the 4G network. You don't mix and match. Whereas in case of a non-standalone, which is a Bharti system, you typically mix and match. You have got 4G and 5G both running together in the same network. Okay, I'm not going to go further than this, otherwise the video will become too long. Now, why you need an SA network? Because as I told you, both the systems are sharing the same media, the same cloud system. So for the FWA to work efficiently, they need to be, their traffic needs to be prioritized when it is running in the cloud through the CDN. If it is not prioritized, it is going to be the same way the mobile tariff system which the traffic is moving, which is on a best effort basis. Then you will not be able to give the customer the same kind of experience that you want to give, because likelihood some of the FWAs are going to get congested depending upon how the mobiles are using the system at a particular point of time, right? So you need to give priority. You need to prioritize the FWA traffic when it is running through the cloud system. For that, it can only be possible in a 5G SA system through network or the UE level slicing applications. That is not possible in an NSA system, because NSA system are primarily LTE system with an LTE common core, where the 5G is also moving and getting aggregated together. So therefore, now we might have seen Bharti making announcement that they are going to use 5G SA for their FWA system. It is because of this reason. They can't offer FWA in a system which is common for both mobile as well as for FWA without prioritizing the FWA traffic. Okay, so this is because this system is sharing both mobile and FWA sharing both the pipes. Now we have already completed my presentation. I am going to summarize. The summary is very simple. What the summary is that the FWA system can enhance spectrum efficiency significantly, because it can slice the physical space into multiple channels, physically separated channel, and those channels will have a different capacity limits driven by the Shannon theorem, right? If you have a common beam, then that beam will be shared by all the devices, and one beam will have the limitation of the Shannon theorem, and therefore you will not be able to escalate beyond the capacity of that pipe. FWA systems are more effective in higher frequency, I've told you, because you can pack multiple antennas in both in the base station size as well as in the mobile side, and then you can have multiple such beams which are going to be very narrow in nature. FWA systems are asymmetric. Download speeds are significantly higher than the upload speed, unlike OFC. I have explained to you that. FWA system needs 5G standalone network to work effectively. I told you the reason why, because the traffic has to be prioritized when they are sharing the same cloud which the mobiles are also running. And FWA can play a significant role in expanding broadband connectivity of our country. And probably you know that. Why? Because you don't have to deploy last mile cable. Last mile cable is the biggest challenge. And if you are going to have the last mile link on FWA, then you can imagine that how fast we can able to increase our broadband teledensity of our country. Now friends, that's all. 22 minutes have passed. I hope that I have been able to cover everything in such a short window period of time. And I hope that you have found this video useful and interesting. And thanks a lot for listening till the end. And I'll come back with a new video next time with a new topic. And let me know if you have anything new you want to cover in this series of presentation. I will definitely take your request, and I will try my level best to cover that topic as well. Thank you very much for your time.